You ready for the spy training program today? We're going to do some secret codes using matrices. So hopefully it'll be some fun. Uh, I got into this lesson. I said, "Oh yeah, this is why I like this particular thing. What we can do with it." So we're gonna go back. Um, Monday's lecture. We're going to finish a couple pieces up so that kind of some examples from the homework, what to do. Remember, we were reduced row echelon form, which was a matrix with ones along the diagonal, zeros everywhere else. And then there was the last column was basically the answers, right? The X, Y, and Z. What we're going to look at today is what happens when we don't get that nice little thing. There's two things that could happen. If there's not a single solution, there could be an infinite number of solutions because basically one of the lines is on top of each other or something like that. Or there could be no solutions, and we'll see both of those examples. And then we'll jump right into today's, which is going to be using getting inverse matrices and something called a determinant. Uh, but what we're going to do is I'm going to focus today on how to do it and how to sort of solve the problems using the graphing calculator. There's a section that will talk about how to do it by hand. We might go through those fairly quickly today because it even tells you that this method that they use only works for small matrices in special cases. But what we're going to do with the calculator will work in every situation. That's what you need it for. So if it only worked for the simple stuff, why use it? Because there's actually easier ways. So the more complicated one, we really have to use technology. So we're going to focus on the technology today. Friday, we'll pick up whatever little pieces need to be picked up. And then remember, I'm going to be moving forward what was scheduled for Monday, we'll do on Friday. So that gets us a day ahead. So the Friday before spring break, we can have just as a complete open work day. If you have other plans to travel, that's okay. But if you have questions, we'll be here and we'll have time to answer them. But it still gives us that extra day that was sort of in here anyway. So any questions before we begin, or comments, or important things? Sky isn't falling or anything, so yeah. So we're safe here for at least the next hour. We'll see what happens afterwards. Never know about this world these days. Let's see what's happening over in California. That flooding, and oh man, it's terrible over there, especially on the coast. So here we are. This is what we're looking at doing. This is what's called reduced row echelon form. And our calculator, as we'll see, does this. It has we enter the matrix. We go to that section of math. We go down to RREF, reduced row echelon form. That's all we really need to remember, RREF. We click the, basically get it going, and it'll give us this if it exists, okay? And remember, this is saying remember, these columns are X, Y, and Z. In this case, if there were more columns, they could be other variables. And then this last variable, remember, this is an augmented matrix, so this is like an equal sign along here. These are the answers. So this is saying 1x equals whatever number's here. 1y, I guess I should come back here, equals whatever number's here. And then 1z equals that number. So that's what we get. So we're going to look at a couple ones. This is called an inconsistent system. What do you think that means? Probably means there's no solution. I think that's what it means, but sometimes I forget these things. So let's see what it means is, I don't know, let's just put it in. Actually, let me go back. See if I can go back to that. Before we put it in, just sort of a reminder of how we get our matrix, right? It's the coefficients in front. So there's a 1x, 1y, 1z. So our matrix we're going to enter is going to be 1. Oops, getting too big. First of all, we've got 3 equations, so we'll have 3 rows. We've got 3 unknowns with a augmented part, the equals part. So it's going to be a 3 by 4 is what we're going to put in. And we'll have a 1, 1, 1, for those are the coefficients in front of the x, y, and z. And then the 1 over here goes there. So that's equals 1. Then we have a 2, negative 1, 1, 0. And then we have a 4x, 1y, 3z equals 3. So that's the matrix we're going to enter. We're going to get our calculator to try to get it into reduced row echelon form, and then we'll talk about what we end up with. Okay, so this is kind of how you're going to do all the homework. On the test, it'll be the same. When we get to the test, if there's any sort of by hand things that you're going to need to do, they would be sort of like do this one row or something. So don't worry about trying to solve something like this by hand. There is no valid reason that I can think of to do that. So what we do is we come to our calculator. Let's see. I want to have both open at the same time. How do I do this? Okay, so I think I have to escape out. So, okay, so if I do, we're going to keep these, and then I bring up my calculator off to the side. Let's make it a little bit smaller. Okay, so we go to the matrix is above the x to the -1, which is another key we're going to use a lot for doing inverse matrices. It's kind of cool. So that's really the inverse key. But second matrix, these are the names of the matrix I've already got set up. So I need a new one. I'm going to edit. Let's put it in matrix C. Again, I'm using the TI-84. If you've got one, that's great. The other, there's a NumWorks calculator. If you need an online one to sort of practice with, it works differently. Casio will work differently. So anyway, but learn how to use the technology you have. So this is a 3x4 matrix. So we enter that, and then we just enter our numbers. 1, enter 1, enter 1, z equals 1. And then when I hit enter, it comes to the other side. Then I've got a 2x minus 1y plus 1z equals 0. And then the last line, I'm going to get 4x. See, we don't really even have to write it down. I suppose if, they want you to show your work, you could show that. But, so just as long as you're remembering what you do. But this is what we do. Okay, so that's our matrix. So we enter the matrix first. This is the same thing we're going to be doing with today's lesson. We got to get out of here because actually we're inside this matrix and it gets messy if you try to do things in there. What we want to do is we want to operate on that matrix, matrix C. So we want to do the reduced row echelon form of that matrix. So the way we do that is we go back to the matrix menu, so second matrix. I go over to the math, and I have to arrow down until I come up to RREF. REF does only a part of the job. You don't want that one. You want the RREF. And I just hit enter. And then that puts that in the window, and it says, which matrix do you want to work with? So then I have to go back to matrix. It's not really intuitive, but we'll figure. And we want the name. So this is how we use it. We want to go down to C. And when I click enter, it's going to put that into the parentheses. I finished the other side of the parentheses, and it will do all the magic. And it gives me this matrix. Oh, one thing I forgot. What did I forget to do? Because I got a bunch of decimals, right? How can I get fractions? A second fraction. So what I'm going to do, notice above the entry key, it says, or enter key, it says entry. If I do second entry, what it does is it brings back the last thing I inputted, so I don't have to do it again. And then I'm going to go to math, and that's the first option here is fraction. Turn it into fractions. I'm going to hit enter, and now it's going to get it reduced row echelon form in fraction mode, because that's maybe what WebAssign wants. And it looks a little prettier, right? Kind of cool. And you might have recognized that 0.666 is the fraction 2/3, so you could do it that way too, however you want, but this is kind of nice. So what we see, though, is this is not quite reduced row echelon form, right? It's not 1, 1, 1, and these are all zeros. So these are not zeros, first of all. So what is this? So let's take a look at that first one. So it's 1, this is 1x plus 2/3 z equals 0. We have an equation. So it wasn't reduced down all the way. We also have 1y plus 1/3 z equals 0, another equation. But let's look at what do we have in this last equation. We've got 0 equals 1. Is there anything wrong with that? Could 0 ever be 1? No. 0 is different than 1. They're not equal. And you can't, there's no variable there, so you can't make them equal. We don't have to work with this, so don't, oh, what do I do with these first two? Doesn't matter. The last one tells us this thing, it can't be solved. Okay, so sometimes we're gonna deal with, we'll get some of these, and we might get 0 equals 0, which is true, and then we'll talk about, that's the next example. But take a look down to here. 0 does not equal 1, so it's kind of like that last line. Come back over here. So we got this system. We went R, R, E, F, and what we got 1, 0, 2/3, 0, and then we got 0, 1. What was it? -1/3, or I don't. Like I said, it's not really important. Something equaled something, but then the real problem is we got all these zeros and 1, and so this last equation was 0 equals 1. Not true. And we can't change it or anything, so this is no solution. That's what inconsistent means, no solution. Solution. So you may see some of those in the homework. When you get something like that, just look for that sort of inconsistent part. You okay with that? Okay. So again, a lot of this is just getting comfortable entering it in on the tool, because we need to use these graphing tools. That's why we do matrices, because of technology. It's a numerical mathematics thing. There's a whole thing called numerical mathematics. Here's one we're going to get infinitely many solutions. Again, I'll save us a little time, and we're just going to enter it on the fly into the calculator. But it's a 1, 2, 3, 3 rows, and 1, 2, 3, 4 columns augmented matrix. So let's pull up our calculator again. Let's go to matrix, and let's make a edit, and we'll put it in D. Again, I'll show you again before too long how to clear out matrices, because it's real easy to get a bunch of it, and then you forget which one you're working with, and so you want to clear them out. So this is going to be a 3 rows by 4 columns augmented matrix, and it's going to be 1x plus 1y plus 1z equals 1. Okay, so that's our first row. Second row is 1/4. I think we just enter it as 1 divided by 4. Let's see what that does. It does a 0.25. Let me back up just in case. I mean, there's nothing wrong with that, but if you wanted to have it actually stay and look like a fraction, there is this F1 key. So F1 is actually green. If I do alpha F1, it will actually let me put in a fraction, numerator over denominator. I'm going to do that, and I'll put in 1/4. Again, that's still 0.25 is a nice decimal, but if it was 1/3, it might be 0.3333, and it gets messy looking. Anyway, and then -1/2, I'll do the same thing. I'll go alpha F1, pull up the fraction template, and let's put in -1. Go down over 2, so -1/2. That's looking nice. And then 3/4 alpha F1. Get my template and put in 3/4 equals 0. So I just put 0. Last line, we've got 1x plus 7y minus 3z. Notice we're just putting in the coefficients, just the numbers, equals 3. We got it there. It's the hardest part, getting that part right. And then what do? Same thing. We go back to the main screen, to the calculating screen. Second, quit. So I always do the second button to do the blue features. I'm going to ask for it to do reduce row echelon form. So I go second matrix. Okay, so you want to practice this, because your finger will remember the buttons. You might forget, but your finger will remember if you do it enough times, or your thumb, whichever you're using. Yeah. Let's see. I go over to math. Actually, let's try going up. Sometimes if you go up, it's a little bit quicker. because you're going from the top to the bottom. Yeah, reduce row echelon form. That's what we want. We need to put the matrix that we want in there. So we go second matrix again. This time we go over, oh no, we stay at names, and we remember that we put it in the D matrix. So we're using matrix D. We hit enter, or I don't know, you put the parentheses, it looks prettier. And then again, we might have some fractions. So how do I get fractions? Math key, fraction. So if there are fractions, it'll be there. If they're all integers, it's fine too. And then I hit enter. And yeah, there was a few fractions that would have been kind of weird looking decimals, 0.33. I don't know, weird, but anyway, so this is what we got. Now notice this last line is a little different than the last one. It still doesn't, it's got all zeros, but it's 0 equals 0. Is that true? Yeah, 0 is equal to 0. It's the same thing. So that's okay. This is not no solution like the last one where we had 0 equals 1. So now we got to deal with these two equations because we did not get an answer that x equals just a number. We got two new equations. So let me see if I can remember this. This is x. So remember this one here represents 1x. The 5/3 represents 5/3 z equals 2/3. And then we've got another equation. So let's see if I can write here. Let's see. 1x is 5/3 z equals, I already forgot, 2/3. Thank you. Yes, yeah. You guys are young, and I need to start taking some of that Prevosec or whatever that memory stuff is from the not goldfish, jellyfish. I don't know, see those commercials. Anyway, but that stuff's expensive. It's like $50 a month. I know, yeah, it's like, okay, where were we? We're here. Okay, and then we want y minus 2/3 z equals 1/3. Okay, y minus 2/3 z equals 1/3. Okay, so those are what we ended up with. In the homework, what they're going to ask you to do is to get your answer in terms of one of the particular variables. Now this one, I think they wanted it, the one they're going to give us, they say, let's get it in terms of z. So you solve for z, and then if you know z, you'll be able to get x and y. So if we do it for z, is a little bit easier. We just want to solve for x, actually. So we solve for x equals negative 5/3 z. So what I did is I subtracted 5/3 z from both sides. I moved it to the other side so the positive becomes negative, plus 2/3. So that's what x is equal to. Y is going to be equal to, so I'm going to add 2/3 z to the other side, to both sides. So I have a positive 2/3 z plus 1/3. That's what y equals. Well, what does z equal? Z equals z. So this is one where it's actually an infinite number of solutions. Give me z, I can get the other two, right? And you can give me any number for z. So we actually have an infinite number of solutions that will work dependent upon what the value of z is. So, but this is the best we can. It's not something that has a single solution. It actually has multiple infinite solutions. And so for my final answer for this one, I would put that x is minus 5/3 z plus 2/3, comma. So this is really in place of my x, my y, and my z, right? And then for my y, I put in that expression, 2/3 z plus 1/3. And then for z, I just put in z. Okay. Now in the homework, I think they ask for give it in terms of x. So you're actually, when they want it in terms of x, that means it's kind of backwards how you would think, right? We want it in terms of z, so first thing I start thinking, I should solve for z. No, solve for the other variables in terms of z. So when they want you to write it in terms of x is just going to be x, right? It's the thing you can solve. And then y and z will be some sort of expression, okay, in terms of x. So you solve for the other variables, and each of the expressions would have x in it instead of z. This one was easier to look at. Let's solve it for x and y, so that the z is what's the determining factor, and then z is z, and x and y are some sort of, once we know z, we go. Does that make sense? Okay, so I think there's maybe one. I know there's one. There might be two, but there's not. No, so these are infinitely many solution things. Okay, we're doing on time. 8:20. Okay, I want to kind of keep moving. Let's go back here. I think that's pretty much it. So the other thing we can have now, I said, like, if we have three unknowns, we need three equations, but we could have more. So if we have two unknowns, we need two, but we could have three. That would be called an overdetermined, which means we have more stuff than we need, more information. And sometimes what happens is that's redundant information, but we just put it, we don't care. We would just put all the equations into a matrix, get it into reduced row echelon form, and we do there. There are some that could be underdetermined, which means like we have three unknowns, but we only have two equations. We're probably not going to be able to solve that thing. It could sometimes be, but again, we just put the matrix in and go ahead and do it. But if we've got three unknowns and only two equations, we're thinking we probably aren't, it's not going to have a single solution. It might have infinite solutions or something, but we go from that. Okay, so here's just an example. There's two unknowns, x and y, but they gave us three equations. And if you solve this one, you kind of see it here. If you take this middle equation and if you multiply it by 2, 13 times 2 is 26. Oh, maybe it's the other way. This is 26 divided by 2 is 13. I thought I might have been looking at something else. Sometimes one of the equations is like a multiple of the other. This one, I don't know, it's kind of a mix. So I'm not going to worry about it. But if you do this system, I think you end up with the last line of 0 equals 0. So you still get the solution. If you do the matrix, you'll get a matrix that's 1, 0, 0, 1, 0, 0, and then you get 0 here. You get 5/13 here, 8/13 here. So it still solves out just fine. It's just telling us that last equation was sort of redundant information. Okay, it was maybe it was the first one, maybe it was like a multiple of the first one or something. But anyway, again, just put all the equations in, the coefficients, into a matrix, augmented matrix, reduced row echelon form, and then again, in this case, if you get 0 equals 0, that's information that's not interesting, and then we've either solved it or we've got infinite solutions. Okay, and that's what they're talking about. Some equations may be redundant. If they're not, if we get that 0 equals 0, or if there's multiple, that one we had with z, that's called a dependent. It depends on what z is, but then we have many different solutions depending upon whatever z is. And I think we did one like this, so we're going to work with some more. We'll also take there's another method we're going to pick up today that can solve it without actually using the reduced row echelon form. Still using the technology, but we'll see it's a little bit kind of using an equation. Okay, so, and here's an example solving by hand, so you can kind of compare. What I want you to do with the by hand ones is just be able to look at it and say, okay, this is what's going on. This is what my calculator is doing in the split instant of a second, for me when I just do the thing. So that's what it's all doing for us. It's only multiplying and dividing and moving things around. But we don't have to do that anymore because we've got the technology. Okay. And as we get larger matrices, they become almost impossible to do by hand. Okay, so we're done with that lesson. And we have, I'll discard that stuff. Okay. What I'm going to try to do is not talk too much and move sort of just to the important stuff. So what we're doing today, matrix inversion. So we're getting the inverse of a matrix. Okay. What I'm going to focus on is the important keys on the calculator, which we've been using, right? we'll go with red. One of the big keys is here, the matrix key, so the second matrix. But today we're also going to use this x to the -1, which is an inverse key. It gives us the inverse. So we're going to use that quite a bit. And that's pretty much, and then doing that. And then remember the F1 key for making fractions. So that's a alpha F1. We'll use that for the fraction in over D. We'll also use the math key. And for that one, we get that little fraction. I think it's something like that. So that we can have our matrix given to us in fractions, just because that oftentimes is easier to input into WebAssign, and sometimes that's all they'll accept. Okay, they won't take all our fractions or little decimals. Also, when we do second matrix, we're going to be using math, and today we're going to do something called a determinant, and there's a little, that's part of the menu there, so we'll be using that. We'll be using the names part to use the matrix. If we need to use A, we come to names and use it. And when we want to input a matrix, we have to come over to edit, and then we can type over one if we want, or we can go to a new one. But those are the basic three features. So names are a matrix that's already been entered. We can use it. Math is, we're going to do some mathematical stuff with matrix back on the calculation screen. And then edit is where we put in the matrix the first time, or edit it. Okay, so let's talk briefly, try to make it brief, about what an inverse matrix might be. So what's the inverse? We've done inverse, right? We've talked about addition, subtraction, multiplication, but what about division of a matrix? What we're going to do is we're going to say the division of a matrix is basically what multiplication, division is the inverse of multiplication, right? 3 times this is the inverse of 3 something divided. So 3 times 4 gives us 12. 12 divided by 3 gives us back to 4. So that's what an inverse relationship. And that's how we're basically going to do division with matrices. We're not going to get some funky stuff. We're just going to call it the inverse of multiplication. Okay, so you'll kind of see when we do certain things, so, something over here becomes a fraction over here. So 3 over here becomes 1/3 inverse. It's because we're dividing instead of multiplying. Okay, so that's exactly how they define it. So 3 divided by 7 can be thought of as 3 times 1/7, and we can also write 1/7, right, as 7 to the -1. Okay, so we've done this before with calculus and stuff. That -1 exponent is really anything to the -1 power can be written as 1 over that thing to the positive power. So that's the kind of thing we're doing, but we're going to do it with the whole matrix. And again, it's really complicated to do some of these things, and we'll talk a little bit about how you do it if you're doing it by hand. But for us, we just enter it in, we click a key, and the calculator will do all the stuff for us. And again, even you're going to see, I've got it highlighted, the text says, this stuff is really not very efficient to do by hand, so let's use technology. Okay, so we're just doing the same thing with a matrix. We're going to take the matrix to the -1 power, and basically we flipped it. We're doing division with it instead of multiplication. Okay, that's what we're thinking. Okay. And so it has a property. If you take the inverse of a matrix and multiply it by that matrix, you'll get 1. And the thing is, this is the one type of multiplication in matrices that is commutative, right? You can do it in either order, because an inverse is an inverse. I always think, your brother, well, if you're a man, your brother, you're also their brother, or your sister, there's that relationship. Which one's the brother? Well, you're both brothers, right? So one's the inverse? Well, they're both, one's the inverse of the other. You could, however you want to call it. So anyway, inverse matrices, when we multiply, we always get 1. And remember, in terms of matrices, what does 1 look like? It's the identity matrix. So it just depends on the size, but this is the identity matrix. Okay, so we're going to get back to that. So remember, we were seeing that with augmented matrices. So this always comes back. That's the identity matrix. It's, as far as a matrix is concerned, it's the same thing as 1. Okay, because it doesn't change anything when we multiply by it. So when we take a matrix and its inverse, and we multiply them, we'll get the identity matrix. That's one way of testing. So we could do that. And again, they get back to this, something to the -1 power is like 1 over 76. Okay. 76 to -1 is 1 over 6. And if you multiply these two, you get 1. So that's in the number world. Matrix world, same thing. But again, remember, we've got more dimensions and stuff going on. So again, the key part, this little button here, we're going to use it a lot. And that's going to give us our answers. Okay. We're going to talk a little bit about how to get that inverse. Again, if this happens, if we have a matrix times its inverse and we get 1, then we can say it's invertible. Not all matrices can be inverted. Does that make sense? Some, might not get there. In numbers, you cannot invert 0 because you cannot do anything to 0 to multiply it by something to get 1. 0 times 0 is still not 1. So 0 is the one number that does not have a multiplicative inverse. And you can't divide by 0 either, right? So you can't go 1 over 0. Oops, that's undefined. So in numbers, 0 is 1. And then in matrices, we're going to see there's some things that just can't be inverted. So they're called singles, singular. They have no partner. So we think of the inverse as a partner of that matrix, that when we combine those two, we get the identity matrix and we can solve some problems. Singular matrices, there's not much you can do with them. Okay. So again, we'll just look at a few examples. If this is matrix A, they gave us its inverse. We haven't shown how to get it, but we're going to do that in a moment. But they say, and you can kind of see this, right? Well, maybe not. This 1 over 2, if you flip it, it's 2 over 1. But we'll look at how we get this. But they can say it's the inverse because if we were to take and multiply those two matrices, we get the identity matrix, right? So this kind of, if you multiply the two together, you get the identity. And if you do it in the other order, which is, it's supposed to be able to work, you still get the identity. So whichever way you multiply them, we get back to the identity. That means they're inverses. Okay. We're not going to do that much because we're actually just going to click on the button and have it give us the inverse. Is my way of doing it. Okay. So far, so good. So understanding inverse just undoes it, gets us back to the identity. So can this have an inverse? Let's just think about it for a minute. You think this could have an inverse? Is there any problems there? What about that last line? What does that last line say? Can you invert 0? No, that's going to be a problem. So what we could do is we could put it in our calculator, and if we ask it to give us the inverse, it said, nope, can't be done. That's where you get your inverse. So, and so this is a singular matrix, and again, the problem was right here. This part can't be inverted because you can't do 1 over 0. And again, we haven't really talked how to do it, but let's go ahead, and this is the way we're going to focus on, especially today, because I want to get through and look at a few examples, and I want to do the application. There's 2 homework problems using, the last thing I'm going to talk about is coding. So I want to go through the example, and it's not too difficult to do, but I'll give you a resource and a tool. So we're going to enter the matrix in the calculator, so using the edit tool. We're going to place the matrix in the calculation window, and then we're going to hit the inverse button, and we'll have our inverse. Okay, so that's how we're going to approach this to start with. So we've got this matrix, which we've already talked about, 1, -1, -1, -1. And we saw earlier, or at least they told us earlier, that that was a matrix with a bunch of 1/2s, right? Let me see. I want to keep my window open. So let's go there, keep everything we've been writing, and okay, I'm going to remind you how to clear out your, because we got a lot of matrices going. If you go second, memory is down here, the plus key. You can go down to memory management, delete. So we're going to delete some of these other matrices, and we go down to matrix, and it'll give us our list. I'm just going to hit the delete key. I'm going to delete them all because I just want a fresh case. So now I can come back to the main screen. I'm going to clear all this stuff out. I'm going to go second matrix. I'm going to put in matrix A, this one here, a 2 by 2 matrix. So I have to go over to edit, and I put in that it's a 2 by 2. It's the matrix 1, -1, -1, and -1. Again, get used to doing these. I have to remember to quit to get back to the calculation screen. This time, I go to matrix and I want to use the matrix. So under names, A is the one I want. I just hit enter and it says there's matrix A. And here's the cool part. To do the inverse, I just hit this button, x to the -1. Boom. It's going to take the inverse. Beautiful. But before I do that, the inverse might have fractions, right? I'm going to want to say, please format it nicely for me in fraction. So I do this part. There we go. And then now when I hit enter, it gives me the inverse matrix. And if you remember from that other slide, that's what they were saying was the matrix inverse. Okay. There's like 3 or 4 slides we could go through to actually get that ourselves. Basically, you take the matrix and you put, we'll show you in a moment, and you put the identity matrix and you do reduced row echelon form, and you basically get them to switch. And this, what was the identity matrix becomes the inverse matrix. But it's it could be a lot of steps, especially if it's bigger matrix. This was like, I could do this all day, right? It doesn't even make me tired. It's kind of like, kind of fun. You just a few buttons. This is what you're going to do. So we know this is invertible, right? Because it gave us an answer. If it wasn't invertible, it would give us an error. So, sorry, you can't do it. But it tells us it's invertible, and this is what it is. And if you wanted to, you could test it. Oh, let me show you one other thing I figured out. Sometimes we might need to use this again, right? But it's not stored anywhere, but we can store it. This is really cool. There's a button down here called STO arrow, which means store it. So I'm going to click on that and watch what it does. It's telling me it's going to take the answer, which is a matrix, and it's going to store it somewhere. Where do I want it to store it? I want to store it in a matrix. So I go second, matrix, and I come down to B. I think I can do it here, or do I have to go to edit? I can't remember. I think I can do it here. Yeah, actually, I think I go here. I hit there. So, okay, yeah, it's going to take the answer stored in B, and I hit enter. So it just stored that matrix in B. We go back to our matrix. There it is. It's in B. If I need to use it again, I've got it. I don't have to say, but I could also always say matrix A inverse and get it that way too. Okay. So, oops, I don't want to use it. Actually, let's do this since that was sort of a mistake. I'm going to take B times matrix A. What am I supposed to get if I do this? B times A, since they're inverses, what should I see? 1, 1 on the diagonal and 0, 0. I should see the identity matrix. Well, okay, that's cool, right? So you can, play with these and just make sure, okay, yeah, that's what's happening. Anticipate, make it happen. Okay, so we good so far? The cool part is this was what a 1-by-1 matrix. We could have probably done a few steps and done it ourselves, but this is nice because now we've got a tool. We could do a 17-by-17 matrix and it would do the same thing. It would take care of it all for us. Take us maybe our lifetime to do a 17-by-17 matrix by hand. Okay, let's do this one down below it. And then I'm going to show you all the steps that they would have to go through. Good, we're still on track. So let's come back here. Okay, so I want to put in a new matrix. Okay, it's just a 3-by-3. How do I do? Oh, I go second, matrix, and I go to edit. Let's put it in C, since we're starting. We tell the dimensions 3-by-3. We enter all this stuff. And again, this is the tedious part, but it's the important part because if you get something entered incorrectly, usually what I do is I forget, I don't hit enter hard enough or something, or I don't put the negative sign, or, you're not going to get the right answer. 0 and 0. Okay, so there's our matrix. And then I just have to remember I put in matrix C. We want to get its inverse. Second, quit. Second, matrix. Now I come down to its name, C, pull it up to the main screen, and I want to take its inverse. I just hit the inverse button. If it has an inverse, it'll give it to me. Oh, what did I forget to do? Fractions. And I see it, I don't like all those 0.333s. So to save myself some time, I go second enter, which will bring back the entry. And before I hit enter again, I'm going to go to math and fractions, just so it's nicely formatted. Okay. And again, if I forget, not a big deal, just bring it back. But that's its inverse. Now remember, this is not but again, if I multiply this by that matrix C, I will get the identity matrix. That's what's going to happen. E40. Oh. Okay, so far so good. And I'll just I want to at least give you a start. What we may do is on Friday, pick up the rest. Seems like I can never go as fast as I think I can go, but I just need that extra 15 minutes or other time. So here's the ways. If you want to look, what they do is they put the identity matrix over here. They do a bunch of row operations, and then they get that. So you see all the steps that they had to go through to get there by hand. For the bigger matrix, they do the same thing. Notice they basically rewrote the matrix, wrote the identity matrix, and then start doing row operations, which changes the identity matrix eventually, after many steps, into the inverse matrix. Okay, and that's what we're going to do lightly. I'm not even going to worry about doing that. We got a machine that does it for us. Why not use it, right? We paid some money. Let's get some value out of our investment. That's what we do. Okay, and because that method is going to get us other things, 4x4s, 5x5s, that would really be a mess to do by hand. Okay, so we could do all this stuff down, like that's how they do it, but what we're going to do, we're going to skip this. It says it is not a simple process, right? Using the formula for anything larger than a 3x3 matrix is so inefficient that we ain't going to do it. You know, it just take too long, and you'd make too many errors. Calculators are going to do it right. In fact, I've even got an engineering friend. He came to teaching, but he would tell us, he says, when he was an engineer, they didn't want to see your hand calculations. They want to see you run it through a computer, because they trusted the computer. They knew if you did it by hand, they're probably going to make some errors. So that's what industry see. So here's a little bit on determinants. I don't know if, let's see if we can, what time? 42. I think we can get there. So what a determinant is, it's a single numerical value used to calculate the inverse of a matrix. Again, we can do the matrix by ourselves, but in the old days, they found this way of getting a determinant. What's a determinant? Well, on a 2x2 matrix, it's not bad. You're doing a cross multiplication, so you do A times D, and then you subtract the other way, C times B, and that's what's called the determinant. It's not a number that has any real meaning, but if you it's a scalar. If you take that and multiply it by the matrix, you actually will get the inverse matrix. Actually, not, you divide by that. And there's a little thing, but again, we're not going to do that because it only works for 2x2. A 3x3, the formula becomes so messy. You don't want to get the determinant. I've done it before. But you don't want to have to do that. I had chickenpox before, but I don't want it again, right? So you don't want to do a 3x3 matrix. We're going to let our calculators do it. Okay, so but what we can do is we can use an inverse matrix to solve a system of equations. And this is something that's going to be in the homework. So what the system of equations is, so they've got it, so here's 3 equations, 3 unknowns. They've got the matrices here. And basically what this is saying is if you take matrix A times matrix X, which is just a column matrix, right, that's equal to B. What we're going to do to solve this is we're going to multiply both sides. And remember, order is important. So we have to multiply by the inverse of A on this side. We have to do it here. We can't do it on the other side. So order is important. What is the inverse of A times A? It's the identity, which is basically 1, right? So that gives us 1x equals the inverse times B. And what this is going to be a new matrix that's equal to this matrix. So it's going to be a column matrix. And it's going to have numbers here. And it's going to basically will be, say, x is, the first one is x, the second one's y, the third one's z. This is equivalent to what we could have done with the reduced row echelon form. So, I mean, we could do that. We'll get the same answers, but this is sort of a different method, a different approach. Okay, so we'll just say that this will work. So, yeah, so that's what they say, basically take the inverse of A times B. And then when we do that, here's the, B matrix is just a column matrix. We get the answer. Okay. So I'm going to go for one over the homework. This is directly from the homework. It just says use matrix inversion to solve the given system of equations. So again, what we're going to do is matrix A is the coefficients. It's just 1, 1, 1, and -1. And then there's this matrix of the variables, x and y. So that takes us back another lesson we were doing. And that's equal to the answer matrix, which would be 2, 1. Right? So this is A times the variable matrix equals B. And what we're going to do to solve this is we're just going to take the inverse of A times B, and that's going to give us our answer. Okay? So let's just do this. And again, it's not too large, right? Oops. Go there. We'll keep this. Okay, so I'm going to enter. It just always takes time to show this, but I think it's important to show you exactly the steps I'm going through. Oops, not using it. I want to edit it. Okay, second matrix, we're going to edit a new matrix, D, and I'm going to put in a 2 by 2, and that's going to be 1x plus 1y, 1x minus 1y, so that's the A matrix. Then I'm going to go back to matrix and I'm going to edit. I have to put in the B matrix. I'll put that in E. And that matrix is the answers, so that's just a column matrix, so that's a 2 by 1. And I put in the answers 2 and 1. And so I've got my two matrices. And remember, we'll come back here in a moment. Now what I do is I go back to the main screen. I'm going to want to take the inverse of A times B. Okay, so I go second matrix. Now I'm at the names. My matrix, the main one I had was D. I'm going to take that. Remember, I need to take its inverse because I'm basically, it's kind of thinking, I'm taking it from A times X. I'm dividing by it. So that's what that inverse is. I'm going to multiply that. And I think you need that multiplication. I don't think you can just do them side by side. I was watching someone else. Maybe you can. Let me know. But I'm going to be safe here. And then I'm going to multiply that by the matrix E, which is the answer matrix, right? 2, 1. And before I hit enter, I'm going to make sure it's in fraction mode so it looks pretty. Fraction, math, fraction. And there's our answer. X is 3/2, Y is 1/2. Okay. We would have done the same thing if we would have put it in as an augmented matrix and did reduced row echelon form. This is just another method. Again, will the system really know which one you used? Not necessarily, but it's just wanting you to see that there's other ways to do it. And let me see. Oh, I didn't have the, so that, but anyway, if you do it, that's what you would put in, and you'd put in X equals 3/2 and Y equals that. Shoot. I don't want to, we can't do this in a minute. And I know some of you have classes, so we'll do this on Friday. If you want to take a look at it, you can. The thing I added is what we're doing is doing some ciphers. It just talks about the code is setting, let the space key be 0, A equals 1, and so forth. I made this little thing because I kind of need it if I'm going to decode. So that's a little added thing. If you want to look it over, the homework actually talks you through this, but I'll go through it exactly on Friday to start us off. Then we'll do the 3.7 or whatever it is that we're supposed to do, so that we're kind of a day ahead next week, and we only really need to have 2 days. Good. All right. Thank you, guys. Darn, I wanted to get to coding, but spy class on Friday. No, you would only use that if you're going to do some of the stuff by hand. It's just not.
And it gave like a matrix. It was like 1, 2,